Hello my friends and welcome to this educational series in your favorite subject, chemistry. Today my friends, we are going to start our inorganic and analytical chemistry course after we have finished revising the most important and basic perspectives and terms in chemistry. This my friend is the first class in our course in these fields. We are going to answer in this class how to make a chemical compound. Allow me, my friends, before I answer this question, to give you a quick revision for the most important things we have taken so far. Well, my friends, we have started with defining the ion, and we define the ion as one atom or a group of atoms that has a charge. Then, my friends, we said that in terms of the number of atoms, ions have two types. The first type is called the monoatomic ions. A monoatomic ion is one atom that has either lost one or more electrons to become a cation or a positive ion, or gained one or more electrons to become a negative ion, or we called it an anion. The second type is called the polyatomic ions, and a polyatomic ion is a group of atoms, two or more atoms that have one charge and they refuse to be separated from one another ionically, and we should deal with them as one atom only. Now, my friends, we talked about the ions, and we said that in terms of charges also we have two types of ions: the cations or positive ions and the anions or the negative anions. As you see, my friends, here I put this beautiful chart for you so that you can use it and memorize it for the upcoming classes. Well, my friends, before I start answering the question, allow me to give you a small piece of advice about this chart. This chart, my friend, includes the most important ions we are going to go through in the upcoming classes. But also, my friend, it doesn't include all of the ions. So, take this chart, draw it on your notebook, put it on an independent page, and keep spaces or places for new ions that we could learn in the future. Now, my friends, as you see here, the chart has the symbol of the ion, its chart, and its name. We have, for example, a confusing cation, as we called them before. We have the copper, which has two options. The first one is to lose one electron to become charged with +1. The other one is to lose two electrons to become charged +2. We have the iron here, iron 2, iron 3, copper 1, copper 2, using the Roman numbers. We have also here lead 2 and lead 4. What else? I guess that's it. Yes, my friends. Now, my friends, let's answer the question how to make a chemical compound. This process, my friend, is not complicated, but it takes 3 or 4 steps. We are going to learn now one by one. Well, in the first step, I will take into consideration that I should put the positive ions or the cations left and the anions right. As you see, my friends, when you want to write a chemical compound, you should start with the positive ion, put it left, and the negative, put it right. As you see here, sodium, for example, chloride, NaCl, this is sodium chloride. This is calcium oxide, CaO. And my friends, I have only 2 exceptions to this rule, which are the acetate and the formate. Those are the acetate and formate. In their cases, I put the negative ion, which is here, acetate, and formate, I put it left, and the positive one, I added right here, CH3, COO, Na, and HCOO, which is potassium formate. In the next step, my friends, I will look at the charges. And in here, I have two options. The first option is when the charges of the cation and the anion are opposite, of course, but they have the same number, equal numbers. In here, my friends, I join the ions together in a new compound without looking at the charges or the numbers. For example, here I have silver and nitrate, silver nitrate Ag, NO3. Of course, I ignore the numbers. I have Mg, S. Teacher, some students write Mg2, S2, and this is wrong. Please, if the two ions have the same number of charge, please join them together without looking at the numbers or charges, positive, negative. And here, aluminum and phosphate. What about those? Generally, my friends, you cannot join positive ion with another positive ion or negative ion with another one, because as you all know, there is an electronic, or let's say electric repulsion when the two ions have the same sign or the same charge. Now, my friends, the other option is that when the charges are different in their numbers. For example, as you see here, we have lithium +1, oxide -2, calcium +2, and chlorine -1, aluminum +3, sulfide -2, we have ammonium +1 and sulfate -2, iron 3 +3, and we have sulfate also -2. Well, my friends, we have here two situations. Situation number one, when both of them, I mean the two of the ions, are monoatomic, which is very easy. I need only to cross multiply their charges. For example, lithium is going to be multiplied with 2. Of course, number should be small. Oxygen or oxide should be multiplied with 1. And as you know, writing number 1 here doesn't make any change, so I will ignore it. Generally here, we have calcium and chloride. I multiply calcium with 1, which is not necessary to be written, while chloride, I multiply it with 2. Here, my friends, I have aluminum and S. Aluminum should be multiplied with 2, while sulfide multiplied with 3. This is, my friend, simply can be written just cross-multiplying the charges. The problem, my friend, or the real problem in the second situation, when I have at least one ion which is a polyatomic. In this case, my friends, I should go back to the definition of the polyatomic ion. As I said, a polyatomic ion is a group of atoms. Here I have one hydrogen and one nitrogen and 4 hydrogen atoms to make one ammonium polyatomic ion. So I have 5 atoms making one ion, and I should consider them, or I should deal with them as one atom. So I should put parentheses here, and I write NH4 inside those parentheses. Again, my friends, according to the definition of the polyatomic ion, that I should deal with them, all of them, even if they were 1 million atoms inside one ion, I should consider them as one atom. And here, cross multiplication, I multiplied with 2, and I write the SO4 here. So what happens if I don't write, or I don't draw the parentheses? Unfortunately, some students multiply number 2 with number 4 here, so it's going to be 8 hydrogens and only 1 nitrogen, which is not correct. Again, my friends, I have another example here. I multiply this with 2, this with 3, Fe here, Fe multiplied with 2. Again, I have a polyatomic ion, and this ion should be multiplied with a number which is more than 1, so I should draw here parentheses. I write the number outside, this is number 3, and then I take the whole polyatomic ion inside the parentheses, and I deal with them as if they were one atom only. And here, as you see, my friends, I solved this problem. Well, that's it for today, my friends. I hope you enjoyed this class and you learned something new. If you don't understand a point, please try to replay this video again and try to play some Kahoot games which are related to the same topic today. And before I say goodbye to you, I would like to present two questions for you. Take them as homework, solve them, and I will help you with them in the next class. In the next class, my friend, we are going to answer those questions, and we are going to learn how to name the chemical compounds and how to deal with them in the chemical equations. Thank you again, my friends. I hope you enjoyed this class, and good